Imagine, just for a second, that your corporate network is a medieval castle. You know the drill-high stone walls, a moat filled with something unpleasant, maybe a drawbridge that creaks when you lower it.
It's a classic image. It's comforting, right?
Yeah.
Big walls, one way in, one way out.
Exactly. That's the old way of thinking about security. You build a perimeter, you stand on the wall with a bow and arrow, and you just keep the bad guys out. Simple.
But that castle design, in today's world, it has a fatal flaw. A really big one.
It really does, because what happens when the attackers are already inside the castle? Or,
Right.
I guess more accurately for today's world, what if your castle walls are completely invisible?
Invisible.
Yeah, because your kingdom isn't a castle anymore. It's just a bunch of laptops scattered across coffee shops, airport lounges, and home offices. The kingdom is everywhere.
And that is exactly where the perimeter model just completely collapses. You can't just guard the gate anymore. It's not enough.
No.
You need a guard standing next to every single person, every single room, and every single document inside that castle. And that guard needs to be awake 24/7.
And that right there brings us to today's deep dive. We are zooming way, way in. We're looking at the eyes and ears of cybersecurity. Endpoint agents and sensors.
The guards on the
The
inside.
guards on the inside. We have a massive stack of documents here from what we're calling Watchpost security, and we're specifically looking at the heavyweights. We're talking about Symantec now, part of Broadcom and CrowdStrike.
Yeah, these are two titans with, as we'll see, very different philosophies on how to build that internal guard force.
So our mission today is to deconstruct how these tiny pieces of software actually prevent cyber disasters. We're going to compare the cloud-native approach versus, the on-premise iron, and we are going to answer the ultimate survivalist question.
Oh, I like the sound of that.
How do you protect a computer that is completely 100% cut off from the internet?
The air-gapped machine. The submarine scenario.
That's the air-gapped scenario, and let me tell you, the details on that are just wild. We're talking about manual XML editing and something called a sneaker net.
It gets very hands-on very quickly.
It does, but first, let's quickly touch on our source material. We are working with a stack of technical white papers on Symantec endpoint protection or SEP sizing guides, CrowdStrike Falcon administrator manuals, and some really dense architectural docs for zero trust network access.
It's a heavy stack, but it tells a fascinating story.
Yep.
It's really a story about how the philosophy of protection has shifted over the last decade.
Okay, so let's start right there. The philosophy. Let's talk about the thing that is actually running on your machine, the agent. Now, I have to be honest, when I hear the word agent, I get a little bit of PTSD from the mid-2000s.
You are thinking of the system tray from hell, aren't you?
I am. I'm thinking of my old corporate laptop.
Yeah.
You'd boot it up and you'd have the McAfee Shield, then the Cisco VPN lock, then some inventory asset tag scanner, then a DLP agent.
The DLP agent, always the heaviest.
Always. And by the time the machine was actually usable, it was time for lunch. It honestly felt like the security software was fighting the user more than it was fighting any virus.
That is exactly what the industry calls agent bloat. And it was a genuine crisis. You had security teams buying 5 different products to solve 5 different problems.
Right.
And the poor IT ops team had to figure out how to make them all run on a dual-core laptop with 4 gigs of RAM without melting the silicon.
So when we look at this CrowdStrike documentation, specifically from their FHT200 course, they seem to be waging a war on that specific memory. They keep using this phrase, single agent architecture. Is that just marketing fluff, or is it actually different?
No, it's a massive architectural shift. It really is.
Yeah.
In the old days, if you wanted antivirus, you installed an AD engine. If you wanted a firewall, you installed a firewall engine. These were heavy, distinct pieces of code.
Right, separate products bundled together.
Exactly. CrowdStrike's whole pitch, and we see this in their architecture diagrams, is that their sensor is just a data hose.
A data hose, what does that mean?
Think of it like a GoPro you've strapped to the operating system. The sensor isn't necessarily trying to solve every complex math problem locally on your machine.
Okay.
It's just recording what's happening, file access, network calls, process injections, all of it. And it's streaming that telemetry up to the cloud. The brain is in the cloud.
Okay, so instead of my laptop having this massive library of virus signatures sitting on its hard drive, chewing up space and CPU, it's just sending video of the potential crime scene up to a central command.
Roughly, yes.
Yeah.
That's a great way to put it. And that allows the sensor to be incredibly lightweight.
Mm.
But the real revolution here isn't just the weight, it's what they're looking for. This is the whole IOC versus IOA debate.
Right, I saw this all over the docs. Indicator of compromise versus indicator of attack. To me, at first blush, they sound like synonyms. Just, security jargon for bad stuff.
They sound similar, but they are worlds apart in practice. Let's look at an IOC. An indicator of compromise is a static artifact. It's a fingerprint. It's evidence that something bad has happened. Let's say I write a virus called badstuff.exe.
Very creative name.
I try my best. Now, that specific file has a specific hash, a unique digital fingerprint. If a security company finds it on a victim's machine, they add that fingerprint to a big list. An IOC search is just your computer checking that list. Do you have badstuff.exe with hash ABC? Yes or no?
Which works great until the hacker renames it goodstuff.exe.
Exactly. Or they change one single line of code, which completely changes the hash. IOCs are brittle. They are reactive. You are always, always chasing yesterday's threat. It's like having a wanted poster for a criminal who can change their face at will.
See, you're always a step behind. How does an IOA, an indicator of attack, fix that?
IOAs don't care what the file is named. They don't care about the hash. They care about behavior.
Yeah.
They're looking at the verb, not the noun. They're looking for signs that something bad is about to happen or is in the process of happening.
Okay, give me a concrete example, because behavior still sounds a little vague to me.
Okay. Imagine a locksmith. If a guy is walking down the street carrying a bag of lockpicks, that's a noun. He has the tools. Is he a burglar?
Maybe. Maybe he's just going to his next job.
Right. If you block everyone with lockpicks, that's an IOC-based approach. You end up blocking legitimate locksmiths, and they get mad.
Oh, okay. So you can't just ban the tool itself.
Exactly. Now, imagine a different scenario. A guy, doesn't matter what he's wearing or carrying, is kneeling in front of a bank vault at 3 in the morning, and he is actively drilling a hole in the lock. That action is an indicator of attack.
Right. It doesn't matter if his name is Bob or Evil Hacker. The action of drilling the lock is what triggers the alarm.
Precisely. And CrowdStrike's documentation lists these IOAs as these elegant logic chains. For example, a process that is not Microsoft Word is trying to inject code into the memory space of Explorer.exe.
Which is a classic way for malware to hide itself in a trusted process.
It's textbook. No legitimate software should really be doing that. So the IOA triggers an alert. It doesn't matter if the virus was written 5 seconds ago and has no signature in any database. The behavior is guilty.
That makes a ton of sense. But I have to play devil's advocate here for a second. If you're blocking behavior, aren't you going to end up blocking legitimate stuff? I mean, my IT guy runs PowerShell scripts that look pretty scary to an untrained eye. He's drilling the lock, so to speak, but he has permission to be there.
And that is the billion-dollar problem in this industry. False positives. If you tune the IOA logic too aggressively, you stop the IT guy from doing his job, and the help desk phone lights up.
Right.
And this is where Symantec's approach in their documents really caught my eye. They have a feature they call adaptive protection that specifically tries to solve that don't fire the IT guy problem.
Adaptive protection. It sounds like something out of biology, like evolution.
It's a similar concept. Symantec, specifically in their SES, or Symantec Endpoint Security, their cloud product tackles this problem of living off the land.
Okay, you have to explain living off the land.
It's when attackers use your own tools against you. They don't bring a virus. They don't bring their own drills. They use PowerShell or Windows scripting host or WMI tools that are supposed to be on every Windows machine to do bad things.
So going back to the analogy, the burglar isn't bringing a bomb to blow the vault. He's using the building's own maintenance keys that he found under the mat.
Exactly. So how do you stop that without breaking the computer for the actual maintenance guy? The adaptive part in the SES documentation describes using heat map prevalence and event counts.
Heat map prevalence.
Basically, the agent sits there and just watches your specific environment. It's not comparing you to the whole world. It's learning what's normal for you.
Yeah.
It learns which applications usually launch which processes in your company.
So it's building a unique baseline of normality for my network.
Correct. It builds this heat map. So instead of a binary block or allow, it tells the admin, hey, just so you know, 99% of your users never use Microsoft Word to launch a command prompt. But these 3 people in the accounting department just did, all at the same time.
Oh, that is actually really helpful.
It allows you to see the risky behavior of trusted applications before you decide to block it. It gives you context.
Because as an admin, the scariest button to press is block. You are terrified the phone is going to ring 5 seconds later with the CEO yelling at you because you just broke the payroll system.
Exactly. The heat map gives you the confidence to say, okay, nobody in my organization actually uses this feature, so I can safely lock it down. It reduces the attack surface based on your reality, not just some generic best practice template from the internet.
Now, CrowdStrike has a different take on this reaction speed, right? I saw
Yeah.
something in the docs called fusion workflows.
Yeah, Fusion is less about building that slow burn baseline and more about the immediate automated response. It's an automation engine at its core.
Like an if this, then that for security incidents.
That's the perfect way to describe it. The docs talk about configuring these custom workflows. So you can build a rule that says, if an IOA triggers for credential dumping and the host is a domain controller, then instantly email the Tier 3 SOC team, automatically tag the machine as compromised in the console, and de-quarantine it from the network.
It automates the panic response.
Which is absolutely vital because the breakout time, that's the time it takes an intruder to move from one infected laptop to compromising your entire network, can be measured in minutes, sometimes seconds.
You don't have time for a human to read a log file, drink their coffee, and decide what to do.
No way. The agent needs to be empowered to act immediately. That workflow has to fire in less than a second.
So we have two really interesting philosophies here. CrowdStrike is pushing this lightweight streaming behavioral sensor that relies on cloud automation. Symantec is evolving from this heavy on-premise fortress to a cloud-based adaptive system that learns your environment. But I want to get into the weeds now. I want to talk about the actual weapons these agents use, the really technical stuff.
The countermeasures themselves.
Yes. In the Symantec docs, there's a whole section on something called memory exploit mitigation, or MEM. And frankly, the terms in there sound like sci-fi technobabble. I literally wrote them down. Heap spray, C-hop, and nullprot.
They really do sound like spells from a wizard's book, don't they? I cast heap spray.
What on earth is a heap spray, and why do I need to stop it?
Okay, so to understand heap spray, you have to understand just a little bit about how a computer uses memory. Think of the computer's RAM, its memory, like a giant empty chessboard. When a program runs, it puts its data and instructions in specific squares.
Okay, that makes sense.
Now, attackers want to trick the computer into running their malicious code, but they don't always know exactly where in memory the computer is going to look next. It's like trying to land a dart on a specific square of that chessboard while you're blindfolded.
So it's difficult. It's a game of chance.
Very. So what do? They don't aim for one square. They spray the entire board with their code. They fill up the heap, which is the dynamic part of memory, with thousands of copies of their malicious instructions. So no matter where the computer's blind dart lands, it hits their bad code.
Oh, wow. It's like covering the entire floor with mouse traps, so you're guaranteed to catch the mouse no matter where it steps.
That's a great analogy. That's exactly it. And Symantec's memory exploit mitigation, or MEM, is designed to detect that specific pattern. It sees a program trying to fill up huge chunks of memory with repetitive identical patterns, the spray, and it shuts it down.
Okay, that makes sense. Now, what about SUP? That one sounds like a pancake restaurant for hackers.
Not quite. It stands for Structured Exception Handler Override Protection.
That is a mouthful.
It is. Think of it this way. When a program crashes, like Word freezes up Windows, it has a plan B. It has a safety net called an exception handler that says, oops, we crashed. Let's clean up gracefully and show an error message.
Right, this program has stopped working box.
That's the one. Attackers realized they could hijack that plan B. They would find a bug to intentionally crash a program, but just before they did, they would overwrite the plan B instructions in memory with their own malicious code.
No way.
Yes. So when Windows tries to be helpful and handle the crash, it accidentally runs the virus.
That is devious. You're using the safety net as a trap door.
It's incredibly clever, and C-hop is the defense against it. It basically verifies the integrity of that safety net, that exception chain, before letting it run. It checks to make sure no one has tampered with it.
Okay, one more from the list. Stack pivot. What's that?
The stack. In computing, the stack is like a pile of plates at a buffet. It's a structure in memory that keeps track of what the program is supposed to be doing in order. First, do step A, then step B, then step C. The computer just reads the instructions from the top of the stack of plates.
Okay, simple enough.
A stack pivot is an attack where the hacker tricks the CPU, the brain of the computer, to say, hey, don't look at that pile of plates over there. I want you to look at this other pile of plates I made over here. And of course, the new pile is full of their malicious commands.
So the MEM agent is basically watching the waiter, the CPU, and making sure he doesn't switch the trays of food at the last second.
That's a perfect analogy. It monitors the stack pointer, which is the thing that points to which pile of plates to use. If it suddenly sees that pointer jump to a weird, unexpected location in memory that makes no logical sense, it freezes the process.
And all this is happening in nanoseconds.
Constantly, it's incredibly complex math happening in real time, under the hood.
It's just amazing that this is going on inside every corporate laptop constantly while we're just sitting there complaining that Outlook is slow to load.
It has to, because once that malicious code executes, it's already too late. You're in a recovery situation, not a prevention one.
Okay, let's move from that microscopic memory war to something a bit more physical. The candy drop.
Ah, the classic USB drive in the parking lot.
It's the oldest trick in the social engineering book. Executive salaries, 2025.xlsx, written on sticky note, attached to a thumb drive. Someone is going to plug that in.
They always do. Curiosity is a powerful force.
So how do these agents stop that? I was looking at the Symantec breakdown for device control, and it seems incredibly granular. You can get really specific.
It is. It's very powerful. Symantec leverages things like hardware class IDs, these long strings of numbers called GODs, and also specific device IDs from the hardware itself. The documentation shows you can get really specific with your policies.
So you can just say, block all USB drives. That's the nuclear option.
It is, and your users will absolutely hate it, but it's effective. More realistically, though, you can say, allow USB drives, but make them read-only.
Which is huge. That's a really big deal. Read-only means I can copy a presentation from the stick that my colleague gave me, but I can't copy sensitive company data to the stick to take home.
Exactly. It stops data exfiltration in its tracks. Or you can get even more granular and block specific classes of devices. You can say, allow USB mice and keyboards, but block anything that identifies as mass storage.
But the coolest part I saw was the specific hardware ID.
Yes. Whitelisting. You can say, my company has purchased a batch of 1,000 encrypted iron key drives. These are the only ones that are allowed. You get their hardware IDs, you put them in a list, and the policy says only these specific drives work. Any other USB drive that gets plugged in is just a paperweight.
CrowdStrike has this too, right? Their approach to USB control.
They do, absolutely.
Yeah.
Their documentation on it seems to emphasize the exclusion logic a little more, making sure that if you do block things, you have a clean and easy way to whitelist the CEO's new encrypted drive so you don't get a panicked phone call. They seem very focused on the user experience, trying to make sure that a blocked webcam doesn't just look like a broken computer to the end user.
But here's where it starts to get a little messy, I think. We talked about this idea of moving from on-premises to the cloud. The source material for Symantec has this whole section on feature comparison between SEP and SES. And it's not all sunshine and rainbows. There are definite trade-offs.
There are always trade-offs in a major migration like that. One of the things that really stood out to me was the concept of the padlock.
The padlock. I remember this from the old days. In the management console, you'd see a little lock icon next to a setting.
Right. In SEP, the on-premise version, an admin could padlock a setting.
Yeah.
It was a simple binary state. If I, as the admin, padlock the firewall setting to on, the user on the laptop cannot turn it off. End of discussion. The option is grayed out.
Simple, easy to understand.
Very. But in the cloud version, SES, that visual metaphor is gone. It's been replaced by a concept called user control levels. It's a different way of thinking. You set a policy that dictates what level of control a user has over a feature set. It achieves the same goal, but for an admin who has been using SOP for 15 years and is looking for that little padlock icon, it's a jarring change. The muscle memory is wrong.
And there are features that are just missing, too. I saw Power Eraser on that list.
Yes, Power Eraser was this specialized, very aggressive remediation tool in the Symantec suite. It was this scorched earth tool. If a machine was deeply infected, Power Eraser would flag anything that even looked remotely suspicious.
So a high risk of false positives,
Yeah.
but very effective if you knew what you were doing.
Exactly. And the comparison chart in the documentation explicitly says not available in the SES Cloud Console.
Why would they remove a tool like that?
Well, I think that signals a really important shift in philosophy. In the modern cloud-first era, if a machine is so infected that you need a scorched earth tool, maybe you shouldn't be trying to clean it anymore.
You should just be re-imaging it, wiping it, and starting from a clean slate.
Exactly. Nuke it from orbit. Modern security is less about performing surgery on a sick computer and more about quickly replacing it with a healthy, sterile one from a trusted image.
Which brings us to the architecture itself. Because if you are a massive bank or a government agency, you might still be clinging to that on-premise world. You aren't ready to nuke it from orbit or move everything to the cloud. And the Symantec Best Practices for Sizing document paints a picture of just how heavy that on-premise beast can be.
Oh, the on-premise beast. It is a heavy lift to run it yourself.
I mean, to run this stuff in your own data center, you need a management server. They call it a SEPM. You need a big database, usually Microsoft SQL or an embedded one. It's a whole infrastructure you have to build and maintain.
It is. And the scalability section in that doc is critical. If you have, say, 50,000 endpoints, you can't just run one server. You need high availability. You're clustering databases, you're running multiple SEPMs behind a load balancer. It's a serious enterprise application.
But the math that really surprised me was the client-to-server ratio.
Yeah, talk about the push versus pull mode. This part blew my mind a little bit.
Me too.
So there are two fundamental ways the agents can talk to the mothership, to the management server. Pull mode is a simple heartbeat. The agent wakes up every, say, 15 minutes and asks the server, hey, got any new orders for me?
That's efficient. It's like checking your mailbox once an hour. Very low overhead.
It is. But then there's push mode. This keeps a persistent, always-on connection open between the agent and the server. The second the admin clicks Save on a new policy, the server pushes it down to the agent. It's instant.
But there's a cost. There has to be.
A huge cost. The documentation says the maximum ratio for push mode is 500 clients to one management server.
500 to 1. That seems incredibly low for an enterprise product.
It is, because maintaining an open TCP connection, especially if it's over encrypted HTTPS, consumes server resources, sockets, memory, CPU threads. It adds up very, very quickly.
So let me get this straight. If I have a company of 10,000 employees and I want that instant push capability for my security policies, I need to build and maintain 20 servers just for the management layer.
Correct. At least 20. Whereas with pull mode, a single server can handle thousands and thousands of clients checking in periodically. It really forces you as an architect to ask the tough question, do I really need to update policies instantly? Or can I live with a 20-minute delay?
That's a million-dollar question right there. Real-time control comes with a heavy and very real infrastructure price tag.
It always does.
Okay, so that's the fortress, the server in the basement with all its limitations. But let's go back to the coffee shop, the roaming warrior. How do you protect the laptop that has left the building and is out there on the hostile Wi-Fi at the airport?
This is where the whole ecosystem comes into play. You see things like the Symantec WSS agent, that's the web security service, and ZTNA, start to become critical.
The Symantec WSS docs describe this agent as having a kind of split personality. It has a passive mode and an active mode.
It's a really clever solution to the old VPN problem. Think about it. If you are sitting in the office connected to the corporate network, or if you're at home with a full-tunnel VPN running back to headquarters, the WSS agent detects that. It sees that all your traffic is already going through the big corporate firewall, so it goes passive.
It just goes to sleep.
Essentially, it knows, okay, the big firewall back at the data center is inspecting this traffic. I don't need to interfere or slow things down. But the moment you disconnect that VPN, you're at the hotel, you're just on their free public Wi-Fi, the agent instantly switches to active.
It wakes up.
It wakes up and immediately builds a secure tunnel from your laptop directly to the Symantec cloud. It forces all your web traffic through that tunnel for inspection.
And the docs mention it specifically intercepts ports 80 and 443, the web ports.
Right. It's acting as a man in the middle for your web browsing, effectively. And it's smart about it. It checks for tampering. The docs list a bunch of health checks it does, like, has the agent's configuration store been altered? Or are there suspicious entries in the local host file trying to bypass our cloud?
That's the classic high school hack, right? Editing your host's file to redirect traffic and get around the school filter.
Exactly. If the agent detects that, it can lock down the connection or flag it as non-compliant. It ensures you can't just bypass the corporate security policy because you're out of the office.
And CrowdStrike handles this differently, right? Since they don't have that legacy of an on-premise firewall to worry about.
Yeah, CrowdStrike was born in the cloud. They don't really have that passive-active switching concept in the same way because their architecture doesn't rely on an on-premise firewall. Their sensors are designed to always be talking to the cloud. They use things like sensor grouping and update policies to manage different fleets of machines. It's a simpler model, but it fundamentally assumes you are comfortable with everything being managed from the cloud all the time.
Okay, so we've done the office, we've done the coffee shop. Now I want to take us to the most extreme environment imaginable, The submarine, the top secret research bunker, the air-gapped network.
The dark network. This is where things get really interesting and surprisingly manual. The cloud can't help you here.
So we established earlier that the normal standard client is basically useless here because it relies on the cloud for its intelligence. So you can't install that one. You have to install the dark network client.
Which is the heavy lifter. The documentation says it's 80 to 90% larger than the standard client.
Wow. Why so big?
Because it contains everything. Every definition, every virus signature, every heuristic rule is stored locally on the disk. It has to be completely self-sufficient because it cannot phone home and ask the cloud for help or a reputation lookup.
But wait, the logic trap here seems really obvious. A virus definition is only good if it's current. New viruses and threats come out every minute. If I'm completely air-gapped, how on earth do I update this big, heavy client?
Welcome to the wonderful world of the sneakernet.
Sneakernet
By sneakers.
Yeah.
You have to physically walk the updates across the air gap. The documentation describes a tool called the LUA, the Live Update Administrator. You set this up on a server that does have internet access. Maybe it sits in the lobby of the secure facility.
Okay, so the lobby server sits on the internet and downloads the massive update payload from Symantec every day.
Gigabytes and gigabytes of data. Then, and this is the manual part, a trusted administrator has to export that payload, usually to a dedicated, forensically sanitized USB stick. Or maybe they burn it to a DVD if they're really old school. Or, in high-security environments, they push it through a data diode.
A data diode, what is that?
It's a hardware device. It's literally a piece of fiber optic cable with the transmit lasers on one side and the receivers on the other, but not the other way around. It allows light data to pass only one direction. From the low-security network, the internet, to the high-security dark network. It is physically impossible to send data back out.
That is real spy movie stuff.
It's standard for nuclear plants and top-secret military networks. So you move the files across the gap one way or another. Then inside the dark network, you place them on a designated internal web server or file share. And all the air-gapped clients inside are configured to look only at that internal file share for their updates.
So you're essentially smuggling the updates into the fortress every day.
Exactly. But here is the critical catch. All those fancy cloud reputation checks we talked about, is this rare file safe or not? Those don't work at all. The dark network client has to rely entirely on old-school signatures and heuristics, which is basically educated guessing. It can't ask the global community for its opinion.
So your protection is actually slightly lower, even though your client software is 10 times bigger.
That is the ultimate irony. You are cut off from the world, which protects you from direct attack, but you are also cut off from the intelligent threat cloud, which leaves you partially blind to brand new, never-before-seen threats.
Which is why that other piece of the documentation, the XML modifier tool and tuning the Symantec Protection Engine, or SPE, is so important. You need that local engine running at absolute peak efficiency.
You do, because it's all you've got.
Let's talk about that command line stuff, because it feels so out of place with all the slick cloud dashboards. XMLmodifier.exe.
So this is specifically for SPE running on network-attached storage, or NAS devices. In these dark networks, you often have massive file servers. Think NetApp or Dell Esalon. You can't run a Symantec agent on a NetApp storage array. It's not a Windows PC.
Right, so how do you scan the files that are sitting on it?
You use a network protocol like ICP or RPC. When a user tries to open a file, the NetApp filer sends the file over the network to a dedicated Symantec scanning server. It says, here, scan this for me. The Symantec server scans it, sends back a message saying it's clean, and only then does the NetApp let the user open it.
And the XML tuning comes in where?
Speed, performance. Imagine you have 5,000 users in this secure facility. Every single time they open a Word document or a PDF from the shared drive, the storage array has to pause. It sends the file to the Symantec server for a scan.
That would create a massive bottleneck. The whole network would feel slow.
Huge. A huge bottleneck. The default settings in the software might be too low for your workload. The performance tuning guide tells you to manually calculate the max thread setting.
Yes. I saw the formula. It was like max threads equals 3 times the number of CPU cores.
Right. So if you have an 8-core scanning server, you are literally opening a command prompt and typing in XM modifier commands to manually set the threads to 24. If you don't tune that XML configuration file, your users will be screaming that the network is slow because their files are all sitting in a queue waiting to be scanned.
It's just a fascinating reminder that behind all this marketing about AI and machine learning, there's still a systems administrator typing XML commands in a basement somewhere just to keep the lights on.
Absolutely. The fundamentals never really go away.
All right, let's move to what feels like the next evolution. We've talked a lot about agents protecting the endpoint itself, but there's a new philosophy emerging that says, why are we even letting the endpoint see the network in the first place? And this is Zero Trust Network Access, or ZTNA.
VTNA is a huge paradigm shift. It's often called the death of the traditional VPN.
We mentioned cloaking in the intro. How does that actually work in practice?
It works using a concept called a software-defined perimeter, or SDP. In a traditional network, if you scan the public IP address of a company's server, it responds. It says, "Hi, I'm a web server. I'm here."
And the first rule of hacking is, if I can ping it, I can probably hack it.
Correct. ZTNA changes the rules of the game. Let's say it's your internal HR portal, is hidden behind the ZTNA service. It doesn't listen for open connections from the internet at all. It is completely dark or invisible to the public internet.
So instead of having a guard standing at the front gate checking IDs, the gate just isn't there. It's a brick wall until you prove who you are.
Exactly. The gate only materializes for you after you authenticate. And the Broadcom ZTNA documentation we have discusses two main ways to do this: agent-based and agentless.
And I'm guessing the agent-based approach uses that same WSS agent or SEPI agent we were just talking about.
You got it. If you're a full-time employee with a corporate-issued laptop, you have the agent. The agent handles the authentication to the ZTNA service invisibly in the background. It creates something called a segment application. It can handle complicated traffic like legacy thick client apps or things that don't use a web browser. It integrates it with your single sign-on, your SAML provider.
But what if I'm a third-party contractor? I'm using my own personal laptop. Your company is not going to install your security agent on my machine.
That is the perfect agentless use case. For that, you just use a web browser. You log into a secure web portal, and the ZTNA service essentially renders the application for you inside the browser. The docs even mention being able to do SSH and RDP access via a browser.
Wait a second. You're telling me I can get a full remote desktop session to a secure server, but it's running inside a Chrome tab?
Yes. The ZTNA service is acting as the gateway. You see the screen and interact with it in your browser, but your laptop never actually makes a direct network connection to that server's IP address. It's a complete air gap between your device and the target application, bridged only by the encrypted video stream from the ZTNA service.
That is just wild. But here is the piece that ties it all back together, back to the endpoint agent: device compliance.
This is the glue. This is the magic of the ecosystem. The ZTNA documentation specifically mentions its integration with Symantec Endpoint Security for host integrity checks.
Host integrity.
Before the ZTNA service even thinks about materializing that gate for you, it asks the endpoint agent on your device, hey, is this device healthy? Is the antivirus running it up to date? Is the local firewall on? Is the operating system patched? Is the disk encrypted?
And if the answer to any of those questions is no,
the door stays cloaked. You don't get in. It does not matter if you have the correct username and password. It does not matter if you are the CEO of the company. If your device is non-compliant and unhealthy, you are blocked from accessing the application.
it puts the responsibility and the trust back on the health of the device, not just the identity of the user.
It creates a conditional access policy. Access is not just about who you are. It is about the combined posture of who you are and how healthy your device is. And for those contractors without the full Symantec agent, the docs mention they can integrate with a tool called OpSWAT.
OpSWAT.
It's a third-party framework for checking device posture. So even for that contractor on their personal laptop, you can run a quick temporary scan via their browser to make sure they aren't bringing a virus into your clientless session.
Wow. We've covered a lot of ground today. We went from padlocking settings on a server in the basement all the way to cloaking entire applications in the cloud. And we learned that if you're working in a submarine, you need the dark network client and a steady supply of thumb drives.
And we saw that the whole industry is shifting its focus from looking for bad files, the IOCs, to looking for bad behavior, the IOAs.
It's a massive, complex ecosystem. But before we wrap up, there was one little nugget in the WSS agent documentation that I think is a perfect final thought for everyone to chew on. It was about HTTP3.
Ah, yes. The eternal speed versus security dilemma.
So HTTP3 is the new, faster standard for the web. It's built on a different protocol called UDP instead of the traditional TCP.
Right, it reduces latency, it makes websites feel snappier, it makes YouTube load faster. But the Symantec WSS documentation has a specific warning about it.
A warning.
Pretty big one. It says that for highest performance, you might want to consider creating a policy to bypass HTTP3 inspection.
Why would you do that?
Because inspecting UDP traffic is technically much harder for a security appliance than inspecting TCP. UDP is connectionless. It's like sending a bunch of postcards instead of having a phone call. It's much harder for a security gateway to reassemble and track the state of the conversation. It's very resource intensive on the security gear.
So the documentation explicitly says that if you choose to bypass it for speed, I'm quoting here, reporting against the WSS agent is not possible. You are flying completely blind on that traffic.
So that's the final question for everyone listening. As the web gets faster and protocols like HTTP3 become more common, are we being forced to create a blind spot? Are we sacrificing visibility for milliseconds of page load time?
And is your security agent, your Watchpost, fast enough to keep up with the modern web without becoming a bottleneck that everyone wants to bypass?
It's always a trade-off.
Definitely something to mull over next time you're waiting for a web page to load. Is it slow because it's being kept safe? Or is it fast because no one is watching?
I think I'll take slow and safe any day of the week.
I think I'm with you on that. Well, that's all the time we have for this deep dive into the Endpoint Fortress. Keep your shields up and your tunnels secure.
Stay safe out there.
We'll catch you on the next one.